Good morning, my dear students. Welcome to the discussion on the subject Engineering Mechanics. Under Engineering Mechanics, we are discussing a topic on kinetics of particles. Under kinetics of particles, we are going to solve problem based on work energy method related to the connected bodies. This is the sixth solved problem we are discussing under work energy method. Now we will enter into the problem. The given problem is, in what distance the body A shown in figure attain a velocity of 3 meter per second starting from rest. Take coefficient of friction between the blocks and the plane is 0.2. Assume the pulley is smooth. Here body A as well as B connected to the two ends of a string, and the string is passing over a frictionless pulley. Here body A is on 30 degrees incline and body B is on 45 degrees incline. The weight of the body A is equal to 200 Newton and weight of the body B is equal to 300 Newton, and coefficient of friction between inclined surface as well as bodies is equal to 0.2. Now we will write the data. Here the weight of the body A is equal to 200 Newton and weight of the body B is equal to 300 Newton. The bodies are going to start the motion from the rest. So initial velocity U is equal to 0. Our objective is to calculate the distance moved by the body A to attain a velocity of 3 meter per second starting from rest. That is, the final velocity V is equal to 3 meter per second and distance travelled by the body A after attaining a velocity of 3 meter per second, that is S. S is the distance travelled by a body A to attain a velocity of 3 meter per second, and coefficient of friction between the blocks and the plane is 0.2, that is mu value is 0.2. Now we will see the body's movement along the incline. The body's movement along the incline depends upon the weight of the body as well as inclination with the horizontal. Here we will consider the weight component forces of the bodies along the incline. If the weight component of the body along the incline is more, then that body moves down along the incline. Now we will calculate the weight component force for the 200 Newton body along the incline, which is equal to 200 sin 30 degrees, which is equal to 100 Newton, whereas the weight component of the body B along the incline is equal to 300 sin 45 degrees, which is equal to 212.13 Newton. Here, when compared to 200 sin 30 degrees value, 300 sin 45 degrees value is more. That is, 212.13 Newton is more than 100 Newton. So, the body say 300 Newton moves down along the incline, whereas body 200 Newton moves up along the incline. Now we will draw the free body diagrams for body A as well as body B. Here the body B moves down along the incline and body A moves up along the incline. Now we will draw the free body diagram for both body A as well as B on the incline. First we will draw the free body diagram for body A. Here the weight of the body A acts vertically downward direction. Then RA is the normal reaction which is perpendicular to this inclined surface. Because this body tries to move up along the incline, then frictional force acts down along the incline, and T is the tension in the string. FA is the frictional force between body A as well as incline. This frictional force acts down along the incline because the body tends to move up along the incline. Now we will resolve the weight force along the incline as well as normal to the incline. This is normal to the incline, 200 cos 30 degrees, and this is along the incline, that is parallel to the incline, that is 200 sin 30 degrees. Then we'll draw the free body diagram for body B. This body B tends to move down along the incline. So frictional force acts up along the incline. Weight of the body, which is equal to 300 Newton, which is acting vertically downward direction. Normal reaction, which is perpendicular to the inclined surface, say RB. Then frictional force acts up along the incline, say FB. T is the tension in the string which acts away from the body. Then resolve 300 Newton force along the incline as well as normal to the incline. Normal to the incline force is equal to 300 cos 45 degrees. Parallel to the incline is equal to 300 sin 45 degrees. Then we'll calculate the frictional force Fa as well as frictional force Fb values. Here from the FBD of body A, RA is equal to 200 cos 30 degrees, but frictional force Fa is equal to mu into RA. Mu is equal to 0.2, RA is equal to 200 cos 30 degrees. Substitute these values. Then Fa is equal to 0.2 into 200 cos 30 degrees, which is equal to 34.64 Newton. That is frictional force Fa is equal to 34.64 Newton. Then related to the body B, RB is equal to 300 cos 45 degrees. Fb is equal to mu into RB. Mu value 0.2 and RB value is 300 cos 45 degrees. Substitute these values in the equation. Fb is equal to mu into RB, which is equal to 0.2 into 300 cos 45 degrees, which is equal to 42.4263 Newton. Here our objective is to find the distance s traveled by the body A to attain a velocity of 3 meter per second starting from rest. For that we are going to use work energy equation. The work energy equation is total work done is equal to change in kinetic energy. Body B is pulling the body A through this string. So the body movement we are considering it as positive. Here 300 Newton body moves down along the incline, so that 200 Newton body moves up along the incline, because 200 as well as 300 Newton bodies are connected through the string and these two bodies are moving along the incline. Now we calculate the work done of 300 Newton body. Here we are considering forces down the incline are positive and forces up the incline are negative. Here work done is nothing but force into distance. Then the work done by the 300 Newton body is equal to 300 sin 45 degrees into S minus Fb into S minus T into S. Then work done by the 200 Newton body. Here the forces down the incline we are taking it as negative and forces up the incline we are taking it as positive. But we know that work done is equal to force into distance travelled. Here forces are say 200 sin 30 into distance travelled is S. Then frictional force Fa into S, T into S. Here, as I said earlier, upward forces along this incline are positive, downward forces along the incline are negative. Then minus 200 sin 30 degrees into S minus Fa into S plus T into S. Then net work done is equal to 300 sin 45 degrees into S minus T into S minus Fb into S minus 200 sin 30 degrees into S minus Fa into S plus T into S. After simplifying this, we will get 300 sin 45 degrees into S minus Fb into S minus 200 sin 30 degrees into S minus Fa into S, which is equal to minus FA minus 200 sin 30 degrees minus FB plus 300 sin 45 degrees into S. That is total work done is equal to minus FA minus 200 sin 30 degrees minus FB plus 300 sin 45 degrees into S. Then change in kinetic energy is equal to 1 by 2g into WA plus WB into V square minus U square. Now we will substitute the total work done as minus FA minus 200 sin 30 degrees minus FB plus 300 sin 45 degrees into S, and change in kinetic energy, which is equal to 1 by 2g into WA plus WB into V square minus U square in the work energy equation for the connected bodies. Here we have to substitute FA value as 34.64 Newton, FB value as 42.4263 Newton, and WA 200 Newton, WB 300 Newton, V final velocity is equal to 3 meter per second, U is initial velocity which is equal to 0, and G is equal to 9.81. After substituting these values in this equation, then 35.06 into S is equal to 229.358. S is equal to 229.358 by 35.06, which is equal to 6.541 meters. The distance traveled by the body A to attain a velocity of 3 meter per second starting from rest is equal to 6.541 meters. That is, S value is 6.541 meters. That's about the solution for the given problem. If you have any doubts or queries, to write it down below comment section. I will be very happy to answer it. Visit again for more videos on engineering mechanics using the links provided under the description of this video. Keep learning and knowledge sharing. Stay blessed. Thank you.